Hello and welcome to this video. In this video, we are going to discuss about data mining, and more specifically, we are going to discuss about association rule mining using the a priori algorithm. Now, data mining has become so common, and it is one of the most explored areas by data scientists. And the reason as to why data mining is so common is because it enables us to unearth patterns from data. And once we unearth these patterns, we can be able to generate some insights. Association rules mining, on the other hand, is a part of data mining that makes it possible for us to determine the relationships between various datasets or various transactions in a data. Now, association rules mining is heavily used when you want to do a market basket analysis. And what is this market basket analysis? It is basically trying to understand items that are frequently bought together, such that if a person buys this item, they are likely to buy this other item. And if a person buys this combination of items, it is highly likely that they're also going to include this other item. Now, in this case, we are asking ourselves, think of a store that has to organize their products on the shelves. Now, this store has to analyze this data and say, if a customer has been buying these items together, then they must be packaged or they must be put somewhere near one another in their shelves. Even our e-commerce stores, such as Amazon and others that exist globally, they're using this rule so that once you buy a certain item, they recommend others that go together with that particular item. They don't just do that from the blues, they use association rule mining. Now, for us to be able to do this association rule mining, we need to require a set of libraries, and we're going to use Python programming to do a simple basic one so that we can understand it clearly. But before we begin, consider subscribing to the channel, like our videos, share your comments in the comment section, click on the notification bell so that you are notified every time we release a new video. So let's go ahead. The very first thing that we need is to import our algorithm. And in this case, we are going to use the a priori algorithm. If you're using Jupyter Notebook, and it is an older version of an Acorda distribution environment, you may need to install MLXtet. To do so, just do pip install MLXtet. However, if you're using Google Colab, no need because it is highly supported. So a priori algorithm is a classic algorithm that makes it possible for us to analyze transactions and generate association rules. After importing a priori algorithm, the next thing that we need to import is a library known as association rules. This library is the one that will store or will enable our a priori algorithm to discover the various association rules that we have. Then you need to import pandas, and pandas is critical because we need to preprocess our data and convert it from just an array into a one-hot encoding. So once you import these three libraries, you can put them in a separate cell from the entire the rest of the code, or else you can just do like me and put all of them in a single cell. So the next thing is to now create our data set. You can decide to use just a small data set like I have created here, or in an ideal situation, you'll be having your data set in form of a CSV. In this case, we are assuming you are analyzing data for a certain store, and in this store, they have corrected their transaction for an entire period of about a month, and now they have given you the work to analyze it. So you'll have your data in form of a CSV. We have done some previous videos on how to pre-process CSV data. You can watch them in this channel. Now, in this case, I have just worked on a small data, and in this data, we have transactions in form of an array. The first transaction, we have milk, eggs, and bread. So we are saying this is a person who came and bought these three items. The second one, we have milk and diapers. The third one, we have milk, beer, diapers, and bread. The fourth one, we have eggs, beer, diapers, and bread. The fifth one, we have milk, eggs, diapers, and bread. Now, from the look of things, we can be able to tell quite a number of things here. That bread has appeared in four of these transactions. Diapers has also appeared in four of these transactions. And in three, both bread and diapers have appeared together. We can also tell beer has appeared in two of these transactions, and eggs has also appeared in three of these transactions. Milk appears in 4 of the transactions, and you can see that these are just 5 transactions. If you have 2,000 transactions, difficult for you to do those mental analysis. So that's where now this capability of using a priori and association rule mining comes in. So the first thing that we do now from our data set is to create a one-hot encoding. We have discussed previously what is a one-hot encoding and the way it enables us to handle our data in a more better and organized format rather than handling it in form of just an array. One-hot encoding is used both in text data like we have here, it's also used in images and so on. So to create our own hot encoding, what we do is that we create a variable known as one-hot underscore df, then we say pd.dataframe, we pass our data set. Then we take our one-hot encoding that we have put here, and we stack it for purposes of making sure that these transactions are appearing, rather than appearing as form of an array, they are appearing as form of a data structure, a stacked data structure. So we say a one hot underscore hot underscore df is equal to one hot underscore df dot stack. We use the method known as stack to put them in form of a data structure. After we have done that, the next thing is now to create or to apply our a priori algorithm to find the frequent item sets in the transactions. So we create a variable known as frequent item sets. You can also call this variable X or any other name that you desire. So long as remember the rule of the tab, you must follow the rules of naming identifiers. That one is compulsory. Is equal to a priori is the algorithm that we have imported here. One underscore hot df, which is this variable that we have created here for our one hot encoding. Then we have a mean support of 0.2. When we are talking about support, we are simply asking ourselves, what is the frequency with which a given item set or a relationship appears in a data set? And in this case, when you talk about a minimum support of 0.2, we are saying that we can consider anything that has a frequency of about 0.2. And minimum support can be expressed using an expression xy, whereby x is considered to be an antecedent item, y is considered to be a consequent item. And this means, or item set rather, it may not be a single item. And this means if you have bought X, that is the antecedent, now how does it influence Y? That is the consequent. So when you're talking about minimum support, we are going to have minimum antecedent support and minimum consequent support. That is, when you talk about minimum consequent support, how much does the antecedent support the consequent? Or what is the probability that given these antecedents, you're going to have the consequent? When you talk about minimum uh, consequent support or minimum antecedent support rather, what is the probability that having this consequent, you are likely to have this set of antecedents? So I believe we have gotten that very clearly. Use column titles or column names. We have set it as true so that we can be able to see our column headings. Then we go ahead and generate our rules. So rules is equal to association rules. Remember these are library that we imported here. Then frequent item set, which is what we have here. Then we use the metric known as confidence. And the confidence is the minimum support that we have discussed here. And we talk of a threshold of 0.7. Then you go ahead and print our rules. So if we run this particular cell, what is going to happen? That is going to print these rules that we have over here. And you can see that from just these 5 transactions, we have been able to generate an array of 25 possible rules. Imagine that. So there are 25 possible rules. We can barely tell the rules by just looking at these 5 transactions. So 2,000 transactions, how many rules do you think will be there? So in this column, we have the antecedents, we have the consequence, we have the antecedent support. It continues down here. We have the consequent support. See it? We have the overall support. We have the confidence. We have the lift, the average, and the conviction. We are going to discuss all these elements in this video. And if you would like to know more about the a priori, you can look at the documentation of the a priori. In this case, we are going to discuss more about the application of this. So antecedents, we are saying that this is an item or item sets that are first bought. Consequence, these are items, an item or item sets that are influenced by the first item here. And I've put for you the transaction X, Y. Antecedent support, we have said what it is. Like in this case, if you buy beer, what is the likelihood of you buying bread? And now that one would be determined by this metric that we are calling consequent support. So when you say that a consequent support of 0.8, it means that there are high chances that if you buy beer, you're also going to buy bread. When you talk of antecedent support here, now you are asking yourself, if beer, if you know, if we take bread as the consequent, how much does it say that one would have bought beer previously, or one must have bought beer? The probability is 0.4. So you can see that it is quite a low probability. Let us take another transaction here, bread and diapers. If you buy bread, what is the chances that you're also going to buy diapers? So we take the consequent support. We come down here and we first note the transaction. The transaction is transaction 2, IDEX 2, that is. And we can see that the consequent support is 0.8. So it means that there's a 0.8 probability that if I buy diapers, I'm also going to buy bread. What is the probability that if I have bought bread, I must have bought diapers, right? Or my decision to buy bread was it also means that I had bought diapers before I bought this particular bread. It is also 0.8, which means that even if you interchange the items, the same probability holds. So it means that the beer and bread, they are appearing together so many times in our data set. Let's go to our data set and try to see if this is true. If you look at our data set here, in 3 transactions, both beer and bread are appearing. In 2 transactions, the first one here, bread is appearing, no, both bread and diapers rather. Bread is appearing, but diapers are not appearing. In transaction 2, diapers are appearing, but bread is not appearing. And you can see that means that these two have a very strong relationship in our data set. And you can already see how these association rules mining can help us as data scientists to demystify how various items are related. So if I was to advise a store that has been stocking these items, I would advise them to make sure that in their shelves, they have put these items close together so that when you are buying diapers, you can see bread, or when you are buying bread, you can see diapers, right? But in the case of beer and bread, I would advise them that put beer to be more prevalent. Then anybody who buys beer, they look for bread. But now, if somebody has bought bread, chances of them being meaning that they had already bought beer are very low, which means that bread is not influencing beer so much. Let us go ahead and look at a more diverse transaction, or a more detailed transaction, or a transaction with more items. Take an example of transaction number 25. Diapers, eggs, and milk as the antecedents, and bread as the consequent. Let us first go to what we are calling the antecedent support, is 0.2. This means that you buying bread doesn't necessarily mean that you had already bought diapers, eggs, and milk. It's actually 0.2, very low. But what are the chances that if you have bought diapers, eggs, and milk, you're also going to buy bread? That is the consequent support. Transaction number 25 says that it is 0.8. 0.8. This is very strong. So let's go ahead now and say we are still organizing the shelves of a store. It means, in this case, this is somebody who is checking out of the store. I would put bread somewhere they can see it when they are checking out of the store, because they would have already bought these items and then they would remember they need bread, right? But if I put bread somewhere not near where they are checking out the store, they may not remember it, or they may not, their transaction may not be triggered. Look at this other funny transaction here. Transaction 24, beer and milk. How do they influence diapers and bread? So when one is buying both diapers and bread, does it really mean they must have bought beer and milk before? The transaction is 0.2. But what if one has bought beer and milk? What are the chances that they're also going to pick diapers and bread? Transaction number 24. Let's see it. It is 0.6. It is 0.6. So why does it go below transaction number 25? We are now we can already see that transaction number 25, we have 3 items influencing one. For obvious reasons. If you look at our data set, there is a way in which these items are not appearing together. Right? We have bread here, but we don't have diapers. We have diapers here, but you don't have bread, which means in two transactions, they are not bought together. And that must have lowered the probability, as you can be able to see it over here. So I believe that this basic view of these particular transactions has triggered your curiosity into getting into the field of data mining, as well as exploring association rules further. I want now to challenge you to take a CSV data or a CSV data set of transactions in a particular store. You can try maybe and get one online, or if you don't have one that can access that is already prepared for you, you can do web crawling for some of these sites. I've already done a video previously on web crawling. Get the data set in form of CSV, and now try and do association rules mining it. Or else you can go ahead and try and modify this set that you have over here. For instance, you can go and maybe perhaps add one more transaction right here. You can add another, maybe one more transaction here. Let me just add another transaction. Just come and put that, just paste that. Now here, instead of talking about milk and diapers, I can now come and talk of beer. And now instead of talking beer and diapers, what if I talk of beer and eggs? Let's just see what will happen. Run it again, generate the association rules. Now, you can see the association rules now have changed totally. We had initial 25 rules, now we have 11 rules, right? Because what a priori is doing is that it is trying to assess how are these items related? How are they influencing one another? Like now you can see diapers and bread, they are still influencing one another, but now at a scale of 0.6 support rather than 0.8 that was there initially. If you do a heavy transaction like diapers and eggs, the chances of diapers and eggs influencing you buying a bread is 0.6. But you buying a bread, meaning that you had already bought diapers and eggs before, is actually 0.33. So you can see that the transactions you have could heavily influence the association rules that you generate. And therefore, I would encourage you to practice more with this one, something that is going to give you that thrill of joining data mining, and it is going to make you appreciate data science. Thank you so much for watching the video, and please consider subscribing to the channel for more such content. Click on the notification bell, and thank you so much.